Welcome to The Explainer. Today, we are unlocking the actual mechanical secret behind how wealth grows. Seriously, it's a foundational concept that's just hiding right there inside standard textbook math, but it literally runs the entire global financial system. So let's master it.
Okay, let's dive into this. Have you ever wondered what actually happens when your money starts making its own money? I want you to imagine your bank account acting like its own employee. Taking the cash you earn and then working around the clock to earn you even more cash without you having to lift a single finger. That is exactly the power we're exploring today.
Here's our roadmap for today. 1. Borrowing and simple interest. 2. Enter compound interest. 3. The math shortcut formula. 4. Compounding half-yearly. And 5. Changing rates and depreciation. Let's get to it.
Section 1. Borrowing and simple interest. The basics.
To really understand the math here, we have to start with what I like to call the holy trinity of borrowing. First up, the principal. This is your starting point, basically the original money that's borrowed. Next is the interest. Think of this as the premium you pay just for the privilege of using the lender's money. And finally, the amount, which is just the final total money paid back. Keep those three firmly in your mind, okay?
All right, so let's look at simple interest first. The formula is principal times rate times time, all divided by 100. Now, with simple interest, that calculation is only ever done on your original principal, and it stays that way throughout the entire loan period. It's wonderfully consistent, sure, but as we're about to see, it's also incredibly stagnant when it comes to the math.
Which brings us to Section 2. Enter compound interest, the snowball effect.
Now, this is where things get genuinely exciting. Picture a snowball rolling down a hill, packing on more and more snow, just gaining massive momentum. That is compound interest. Remember how simple interest only calculates on the original principal and just stays completely flat? Well, compound interest continuously upgrades its own baseline. The interest you earn actually turns around and starts earning its own interest.
Let's put some real numbers to it. Say you take a starting principal of 1,000 rupees at a 10% rate for 3 years. In year 1, both simple and compound interest give you exactly 100 rupees. No difference there. But by year 2, simple interest is still stubbornly based on that original 1,000, while the compound principal updates to 1,100. And by year 3, that compound baseline jumps again to 1,210. Meanwhile, simple interest is just frozen in the past.
After those 3 years, the gap is glaringly obvious. Your simple interest totals a flat 300 rupees, but the compound interest totals 331. Now I know what you're thinking. That extra 31 rupees might seem tiny right now, right? But stretch this timeline out over decades. Plug in some larger investments, and that little snowball effect, it turns into life-changing wealth.
Okay, moving to Section 3. The math shortcut formula, skipping the tedium.
Because look, as incredible as compound interest is, doing the math manually year by year is just pure agony. Think about it. You'd have to find the interest for year 1, add it to the principal to get your new amount, and then take that new number and use it as the starting point for year 2, and then do all the math all over again. Imagine trying to do this for a 30-year mortgage. It is completely exhausting.
Luckily for us, we have a unified shortcut. Amount equals principal times 1 plus the rate over 100, all raised to the power of n. I know, it looks a little fancy, but it's actually totally accessible. You just identify your starting principal, that's P, identify your annual interest rate, R, and identify the number of years, which is n. Plug those 3 little numbers in, and you skip all that tedious manual math and jump straight to the finish line.
Let's look at Section 4, compounding half-yearly, changing the rules.
So everything we just talked about works beautifully when the interest is calculated annually. But what if the bank decides to change the rules and calculates your interest twice a year instead? This introduces what's called a conversion period. That's simply the exact time frame after which the principal changes. If your interest is compounded half-yearly, that period shrinks from a year down to 6 months, meaning your snowball is updating its baseline twice as fast.
So the crucial point is, to handle this, we just need to tweak our master formula with 2 golden rules. First, divide the annual rate by 2. Why? Because you're only getting half the annual rate per 6-month period. Makes sense, right? Second, multiply the number of years by 2, simply because there are 2 half years tucked into every single full year.
Let's look at a quick example. Take 10,000 rupees at an 8% annual rate for 1 year, compounded half-yearly. By dividing the 8% rate by 2, our new working rate becomes 4%. And by multiplying the 1 year by 2, our n becomes 2 periods. That's it.
The formula seamlessly handles the new rules without breaking a sweat.
Finally, Section 5. Changing rates and depreciation. Real-world complications.
Because the messy reality is, the real world just isn't always perfectly consistent like a textbook problem. So what happens when interest rates wildly fluctuate? Say you have successive rates of 10%, 12%, and 15% over 3 different years. Well, don't panic. You just chain the brackets together. It's the principal multiplied by year 1's bracket times year 2's times your 3's. It's really an elegant adaptation for a chaotic, real-world complication.
But hey, what about when things go down in value instead of up? That brings us to depreciation. This is when the value of an asset continuously drops over time. And the truly fascinating part, the exact same underlying mathematical logic of compound interest applies here too. Use the exact same mechanics to calculate losing money on things like cars or machinery or heavy equipment over time.
Let's move to an actual sale and see how this builds out in practice. If a machine's value depreciates by 10% every single year, we just use the same logic in reverse. Instead of updating the principal upward, we update the asset's value downward. So a 100 rupee machine drops to 90 rupees in year 2. Then you take 10% off the 90, making it 81 rupees in year 3. The snowball is still rolling, but this time it's melting.
So we've seen how undeniably powerful this underlying math is, whether it's building incredible wealth or calculating depreciation. Which brings us to a final, really important question for you to ponder. Is compound interest working for you, or is it working against you? Take a hard look at your own savings accounts, your investments, and definitely your loans. Because as we've learned in today's explainer, once that snowball starts rolling, it does not stop. Thanks so much for joining me, and keep that math working in your favor.